Okay, so two parts, yeah, to the digestive system that I'm going to teach you, because we're going to try to put in as many things as possible into this lesson. So on the left and on the right. So what I'm going to put on the right hand side here is all the chemical digestion. All the chemical digestion, and on the left we're going to add details to the other parts of your digestion. Okay? Now, the mouth is the only place where you will have a process called mechanical digestion and chemical digestion. Now, coming back to the idea of what is digestion. Digestion is breaking down of a large molecule into a smaller molecule. Mechanical means by mechanical way, biting, chewing. You are breaking it down by force. Chemical way means I mix it with enzyme, which you have done in chapter 4. If you remember, maltose can be broken down by maltase, for example. So that would be a chemical digestion. Alright? So mechanical digestion only happens in the mouth. It is due to chewing. So the rest is going to be chemical digestion. So in the mouth, what I do need to know about the mouth, what is digested in the mouth? Is starch is digested into very good job. Maltose. Okay? And that is what hormone? What enzyme? Yes. So since this amylase in the mouth is produced by salivary gland at the back here, so this is salivary gland. So you have salivary gland. The salivary gland produces amylase, so we call it as salivary amylase. Okay, but it is essentially amylase. Okay, so it's salivary amylase, it's amylase, and generally this reaction needs to be at pH 7, close to 7, 7.1, 7.2, that's fine. But it has to be neutral. Okay, that is optimum for the functioning of amylase. Low battery, I know. We can ignore that. It should last the full recording. Okay, so starch, amylase breaks it down to maltose. Keep in mind, you can only absorb into your blood the most smallest unit, which means it has to be the monomer. So what is the monomer for starch? It's glucose. What is the monomer for protein? Amino acid. What is the monomers for fats or lipids? Fatty acid and glycerol. Only those can be absorbed. Can I absorb all those? No. That means the idea here is it needs to be further digested. Okay? But of all the things you eat, only starch will be digested in the mouth. So I put a number of 1 here, which means it's only one chemical digestion in the mouth. Then the food will be rolled by your tongue, and your tongue will push it back into the esophagus. So that's your esophagus. So what do I need to know about my esophagus? Yes, the pause process called peristalsis, which is just a wave of muscle contraction that will push down the food or the digested food. We also call it as bolus, and that is going all the way down to the stomach, one of the major organs here. So that's your stomach. Now, need to remember, what do I need to know about stomach? The stomach contains gastric juice. This is important. So, what is gastric juice? Gastric juice is a mixture of hydrochloric acid, pepsin, and rennet. So these three combines to form what we call as a gastric juice. Now this gastric juice is released by the wall of the stomach. So the gastric juice is all here, and they will break down protein. So this is the breakdown of it. So we have first reaction here. You have protein that is normally broken down to polypeptides and peptides. It's also okay to just say peptides. What is polypeptides and peptides? They're simply smaller chains of proteins. Can we absorb it? No. Remember, the rule is to absorb. You can only take the most simpler monomer. So the idea is it's going to be further broken down along the way. Yes?
Then what's that one?
It's also the shorter forms of peptide, but that's later. It's coming to that. Okay? It's even more shorter. So it's getting shorter and shorter and shorter until it becomes amino acids. Okay. Now, second process is caseinogen to casein. The difference, caseinogen is a soluble protein of milk. Here is insoluble protein of milk. Casein is the protein that's found inside milk. So generally now we are adults, we don't survive much on milk. But if you remember mammals, when you are newborn, you only survive on milk. And your milk is all liquid. So when you're liquid, you tend to move much faster in your digestive tract. So when you're solidified, then the enzymes can basically, it takes a longer time for it to be broken down. So it will slowly, remember, if you are solid form, it takes a longer time for you to be broken down. So as a result, you tend to last longer in the digestive tract, slowly releasing energy throughout the day. Okay, that's the job. So as a baby, as a mammal, you drink milk periodically throughout the day, and it needs to last the whole day to give you more energy. Okay, now caseinogen, the clue I used to remember caseinogen to casein, like which one is soluble. I think just caseinogen sounds like vitagen. Okay, I just use it. Remember that. Or it is liquid, right? So liquid and solid is the difference. And the hormone that converts this is renin. I forgot to mention the hormone that converts this is pepsin. The trick is whatever that ends with IN, pepsin, renin, trypsin, erepsin, all protein breaking down. They are all enzymes that break down protein. Okay? Only two. So there's one process in the mouth, there's two processes in the stomach. Okay? So now we are moving to those are now digested. They will now move into the duodenum, the first part of small intestine. So to small intestine, then large intestine. Alright? And the product that comes out of the stomach is normally called as chyme. Alright? But it's okay if you don't use that word, it's fine. Alright? Then we're moving from here to duodenum, the first part here. So that's the duodenum. I put that here. I'll put that small intestine. But it is duodenum. That's the name of the first part. Okay? Now if you notice, before you reach to the duodenum, you do need to pass a few other areas. Okay? What are they? I need you to take note. We do have the liver here. Okay? So that's the liver. Liver has a lot of roles which we'll cover in the next lesson. But now you need to remember liver's role here in relation to digestion, it produces bile. So I'll put it here, produces bile. I'll come back to how when we learn the liver itself. So produces bile, and then that bile, once it's produced, it will be stored in this structure that you see here. This is known as gallbladder. Okay? So gallbladder, what is the role of gallbladder? Here, gallbladder stores bile. Then there is a duct here, there's an opening here. We call it a duct. So we call that as a bile duct. So whenever you see the word duct is almost like an opening, like a tap. It's how something is released, the liquid is released. So bile duct is obviously how bile is released through the bile duct. So bile is released into this duodenum area. Can you see? I'm just marking it here. Into the duodenum area. Now I said so much about bile, produced by liver, stored by the gallbladder, and then released by the duct. So what is bile? That's the biggest question. It's very popular in exam. Okay? This is what it is. Please remember, so I'm going to put it here. Bile, so I'll put it here like this, emulsifies fat into smaller droplets, thus increasing surface area for enzyme action. Meaning, this is what it simply means. So bile emulsifies fats into smaller droplets, thus increasing surface area for enzyme action. If you take a glass of water and you put 1 teaspoon of oil in it, the oil will form a thick layer on top. No matter how much you stir and you leave it, it's always going to form a layer. Does it break into smaller droplets and spread everywhere? No, it doesn't. Same happens when you eat something oily, it goes down, they're going to form a large clump. that when you have a large clump, very hard for the enzymes to take actions all over. It takes a long time, it's not efficient. Try doing this at home. That glass with a bit of water and a bit of oil. Try adding a bit of soap, hand soap, just a bit. And then you stir. You will start seeing that the oil droplets will break into smaller droplets and the whole solution will become a bit murky. Because what has happened is now the oil has just mixed all over with water. How did that happen? Because the soap has emulsified the fat. Emulsification is breaking it into smaller, many smaller droplets. So I have a larger amount of oil, they will change into smaller, thousands of smaller droplets. Why? Now you have more surface area for contact with the enzyme. Okay, so it mixes here. After mixing with bile, if do you see it passes with this leaf-like structure? That leaf-like structure is our pancreas.